So let's move further with the tree topology. Here you can see the diagram of the tree topology. So it resembles like a tree, in fact, a inverted tree. So this can be the root. You can the analogy in the analogy this can be a root, and then there are inverted branches. So this is a branch of the tree, another branch of the tree. There are further sub branches of the tree. So in this way, this looks like a tree-like structure. So this could be a central hub, a smart switch. This could be another secondary hub, two more secondary hubs, and then there are branches, there are cables through which the nodes are connected. So in this way, the main thing is that this particular topology looks like a tree, sort of trunk for the network, and the nodes extending outward in the branch-like fashion. So this is the main analogy, and that's why it is called as tree. So here, if you compare the tree topology with the star topology, then in case of star topology, you might recall that there is a central hub or central switch, and this central switch is getting connected, being shared by all the nodes. But here, it is little different, and here there are more hubs can be connected, and in this way, the network can be expanded. And the main advantage of this particular structure is that it is extremely flexible and scalable. So whenever it comes to addition of a new node, you can simply add the node, you can add a hub, and then you can add the further network. So it's very flexible, extremely flexible. It's extremely good for scalability, and these are the main actually advantages, features of the tree topology. So whenever it comes to supporting the spread out devices, this is the topology which is being preferred by the designers. Now there are advantages and disadvantages of tree topology. So tree topology, you can see it's a sort of combination of star topology and bus topology, and having more advantages as compared to both of them. So it's very easy for expansion, network expansion. As we have seen, scalability is very good, flexibility is very good. Troubleshooting is also a straightforward process because it is systematically the network is categorized into branches and then sub branches. So as far as the troubleshooting is concerned, it's very easy. Of course, there are some drawbacks. The drawbacks is that the health of the network, because as you go on expanding the network, and if suppose in the diagram you can notice if the central hub fails, then the entire network will be down. Of course, the branches are connected, and in the branches also, whenever a certain node which is supporting that branch gets down, then the entire branch will be down. So then the connectivity won't exist between the spread out node, which is at the extreme sides of the network, with the central hub. So this is a kind of drawback we are getting due to hierarchical complexity, and this hierarchy is also resulting into sometimes the network administrator finds it very difficult to manage the network because it is expanding like anything, and then so many active hubs, active devices, the network administrator has to take care of. So another thing is that adding certain devices like this, and nowadays because you get the smart devices, of course, at bit costly, and then it adds to the cost of the entire network. Uh, Cabling is also a little bit more cabling is required because you need to connect all these devices, and whenever these cables they get some fault, then again there is a issue with the upside up uptime of the network. Another very practical topology is mesh topology, and here it looks like a mesh where the nodes are interconnected. It can be a full mesh or partial mesh, as the name itself indicates that there exist alternate ways of connecting the devices. And in case of full mesh, the full interconnection. So full interconnections, every node is connected to every other node. So that's the kind of arrangement we have in case of mesh topology. Here you can see it in the diagram as well, that these are the nodes, and these nodes are connected. Every node is almost every node is connected to every other node by using different routes, different data paths, and this is a wave-like structure. So this is actually sometimes gives advantages as well as drawbacks also, because routing of the data, because there will be a flood of data, because data is being transmitted and received in so many number of alternate paths, and you require some special protocols to handle this. So therefore, when the data is routed, there are some logic which is required so that there will be no conflict, there will be less collisions of the data packets, and therefore, even whenever you transport the data, then the nearest neighbor path needs to be chosen, which is the nearest path, so that data can be transmitted over that path, so that there will be less delay in the transmission of data. So all these things are written as a part of software, and that is called as protocol. And there are special protocols to deal with the data transmission in mesh topology. Of course, there are a lot of advantages. The advantages are the reliability is very good, because here there exist alternate paths. So if one path fails, then the other path is there to take care of the data transmission, and therefore very stable kind of networking environment you get with this kind of mesh topology. Degree of interconnectivity is also more in case of this topology. So actually the uptime, you can say it can lead to theoretically 100% uptime. Of course, the drawback, the flip side, is that they are incredibly labor intensive, because so many data paths, so many cables, so many configurations. So deploying the entire thing will be time consuming to set up the things. And the other thing is that it is a costly affair, because you need to have so many cablings, so many connectors will be there, and then connecting all these things. So very costly affairs. So this is a drawback of the mesh topology. Like coming to the last topology, that is hybrid topologies. So hybrid topologies, they combine. So far we have seen the ring topology, star topology, burst topology, then mesh topology. Hybrid is a combination of more of all these topologies. So it is nothing but it combines two or more different topology structures. Uh, it could be a tree, then bus might be there, or star might be there in the same topology. So this is a very practical topology. You will find it in the networking, because whenever you think about deploying a network in a campus, in a big campus, big physical space, then having one particular topology is of no use. So in that case, you can definitely think about the hybrid topology, and you will find this topology is being used, being deployed in larger companies, where there are individual departments. They can be connected with one particular topology, because there will be some departments which do not require large amount of data transfer, not more bandwidth, so they can be satisfied with a primitive kind of topology. But where more bandwidth is required, then you can have the fiber optics kind of connectivity. You can have proper topology, and then in this way, it's a combination of all these topologies. And hybrid is a practical topology. You will find it in larger organizations, where there is a personalized approach is required for the departments, individual departments. Typically, it looks like this. You can see the diagram. So you can see this is the ring topology, and this is a star topology. And in a way, this is a burst topology, a combination of all this, right? And that's why it is called as hybrid topology. So you get all the advantages. Where you require less traffic, you can lay down the ring topology. Where you require more traffic, you can have the star topology, and in this way, you can combine the things. Obviously, there are advantages. The advantages are the degree of flexibility is more, few limitations. There are very few limitations on the network structure itself that the hybrid setup can't accommodate. So, lot of advantages. The most important advantage is personalization. If there are more number of departments, you can personalize the connectivity, the personalize the topology as per the department, so that they get the proper usage of the network. Of course, there are some drawbacks also. The drawback is it whenever you lay down such networks, there are different kind of combinations, and then the complexity is more. So it requires a lot of experience to handle such networks. The I would say laying down the network, deploying the network would be easy, but maintenance of the network is little difficult. So, coming down to the last part, which topology should be chosen?